pretty much the entire section will just be the instruction will be to simplify, which means like reduce, things like that. So the first question is right here. So this is a square root. So you want to check for squared factors inside this number. Okay. So what is a squared number that goes into 45?
9.
Yeah, it's gonna be 9, right? And if you don't know or if you're unsure, you can always just check the smallest square is 4. It doesn't work. Next square is 9. That one works. So I'm gonna use 9. So this is 9 times 5, right? Now there's a property of square roots to say you can separate factors, but not addition or subtraction, just factors. So this becomes a 3, this becomes 5. The 3 times root 5. So that's all they mean by simplify. So if you get a number in a radical, doesn't matter what it is, either number or algebraic term, just check. Okay.
So when you simplify 9 and it becomes 3 and you have 5, then you just put the 3 on the outside.
Hmm. Yeah, you can think of it as this 9 coming out as a 3. Correct. But this is why it happens. So there's a property that says um, if A and B are greater than 0, then you can do this.
Is this generally the basis of this?
This is a review section about radicals.
All
So
right.
we're using this old property here that lets us do this.
All right.
Okay, so for the most part, all the questions are going to be something like this, but they're not all going to be numbers. So let's look.
Some could be like square root, cube,
It could be what's it called? Could be
variable.
variables and numbers. Could be whatever. The same principle. Let's do one more number and move on. So the square root of 125. So that's the same as um 25 times 5, right?
Yes.
So it's same deal, right? We found the square number, separate it, square root it, and we're done. So an alternate way to think about it is you could say, you know what? Square root of 125 is the same as 5 cubed, right? So since this is an index 2 square root, right? Root 2, we know that 2 of these will be used. So the 5 square and a 5, so 5 comes out. It's all the same. That's why the square root of 25 is 5. It's because of this. No, I know people memorize that, but why is it 5? This is why. The square root cancels the square. Any questions on the first two problems?
Um, for for 125,
Mhm.
for when you when you square rooted 25 to 5, and then the alternate method where you put the square root on the outside could um How come there's a 3 and then there's a 2 on there? Like,
Well,
again.
this all square roots are root two. I'm just reminding you. It's always
Ah.
check. One writes it ever. It's understood to be there.
Oh, and another thing, does it matter how we answer it? Like, if we were answered like square root of 63, then we can do the same thing for it? Like, is there
Um,
like a two-way method to answering?
the method for simplifying numbers in a root is to find squared factors. That's the method. Like we were looking for a squared factor, it was 9. This one had 25. So you got to find it, break it apart, and then simplify.
Oh, all right.
Okay, let's see here. 25, 26. This is number 5 from your homework. Oh, I think the instructions are different. Again, I'm hoping y'all watch the videos because this is theory you should know now at this point. Determine the real and imaginary parts of the complex number. Okay, so here is the complex number. So complex number is anything that's a real number or also imaginary. Has an imaginary component. Okay. So if you have an I on it, that's your imaginary part. Complex number is just what type of number, like a real number, a complex number. So this is the entire thing is a complex number. The real part is the 7, right? The imaginary part. Well, actually, that's not true. Is the 0. So there's always a 0. The imaginary part, oops, let's see right there, is the 7i. Okay, so all complex numbers are written in the form a plus bi, where a is real part and bi is the imaginary. Let me scroll up. Okay. So notice on this example, there was no number in front. So there's no real part. So we put 0 because we could not write it as in this form, a plus bi. So there's no a, so you put 0. The bi was the 7i. So if you look at this question, let me show it to you. Right here. So I only have the imaginary part. So you put the 7 part here. The 0 is the a. So this right here is a. This right here is the b. So don't put the whole bi, just put the b. I think I put I by accident. There we go. That's what they want to see. Does that make sense? It should always be in this form.
Does that apply to if it says something like a minus bi as well?
Yeah, that's just the negative version. You could just say a plus a negative b. So the negative b would be what you write down.
Okay.
I'm quite confused.
What about? Well, what's bothering you?
So how come the real part is a zero? There's no zero.
There's always a zero, right? You
The
agree
a
that
isn't there, so it's implied zero.
I can always add zero to anything I want, right? It doesn't change anything, so it's technically there.
Yeah, so if it's not adding anything, that's just the imaginary part. The real is implied to be zero.
Yeah. Hmm. So if they want to know what this is, right? You would say, oh, that's simply 0 plus 7i. If they wanted this exact thing for this is what you write, but they're not asking for that. They just want to know what is the A, the real part, and what is the B, the imaginary part. So that goes here. Okay. That makes sense?
Yeah, I kind of got a question wrong, and I don't know why.
Oh, the same one, or what do you mean?
It was square root of 63.
All right, we can talk about it after lecture. All right, going to number 6. Let's see here. This one has a negative. Okay. You remember how to deal with negatives?
No.
Real quick. If you watch the videos, this is in the definition. The square root of -1 is equal to I. This is the definition for I. Okay, so if you have a square root, this is number 11, 12. 6. So separate the negative. Then do the same thing that we did before, the simplification. So this is simply an I, right? By definition. Square root of 121 is an 11. So your answer is just 11i. We always put the I second, but it doesn't, these are equal, but this is more proper. So just remember this definition here. Let me make you some notes real quick, just in case. So I squared is equal to -1. I cubed is equal to -i. I to the 4th is equal to a +1. Just in case it comes up. Any questions on 6?
Yeah, so apparently when it's I square,
Mhm.
then it becomes a -1. So if you so how did you get I square and then is that 11?
That was there's no squares on this example.
Oh no, but I see an 11 next to in the I.
Mhm.
Does the -1 turn into an I?
Right, that's the definition right here. Square root of -1 is I.
So whenever it's a -1 or an I, then it's the other.
Yeah, square root of -1 will come out as an I. Square root of 121 is 11.
Okay.
So multiply them. This is your answer. So let's do one more. So remember, if you have a negative, technically you can skip to the answer, but I want you to just understand where it's coming from and also how this reduction is done. So this would be -1 times 6. This will be I times root 6. So square root of -1 is an I. Square root of 6. Square root of 6 doesn't have a root, so just leave it alone. It does not simplify. There's no squared factors inside 6. So you can't do anything. Okay? Can't do a thing.
Mm-hmm.
All right. But let's do one that has to be reduced, and I think this is 8. Forget. So square root of -80. So you gotta deal with the negative and deal with the
Ooh.
squared factors. Okay.
Sir, this is good because I'm also dealing with an 80.
Oh, cool.
Yeah. I have the same question.
That's good. Okay. So deal with this one first. That's just gonna be I. So now deal with the 80. So what's the biggest squared number that goes into 80?
16?
16? That sounds right. Yeah, 5 times. It's perfect. The 16 times 5. Let's separate the 16, separate the 5. This becomes I times 4 times root 5. That looks weird, so we put the I at the end. And that's it. Just make sure that your I is not inside the radical when you type it in. It's outside. Any questions on number 8?
Not that I know of, sir.
The rest are pretty much the same thing over and over again, so I'm gonna move on. Oh, last
Just
two.
give me one moment so I can write it down, please, if you don't
Yeah,
mind.
no worries. Sounds good.
Ella, I'm in class.
I got the same question twice, sir.
How weird.
Yeah.
6. This is a little harder because you have to. Oh, actually, maybe not. No, this is not as bad as I thought. So whenever they say and write in a plus bi form, you have to separate the fraction. Okay. So first thing first, reduce before you do anything, right? So this is a negative and a 16. So do you agree that this will become 4i if I skip a step? Right? Because negative 16 is equal to negative 1. Oops. For I. Right? Any issues with this? Right, so reduce the fraction at this point. So factor the 2 out, and we get 1 plus 2i. And on the bottom, you have a 6, which is 2 times 3, right? So you can get rid of that. So now we got 1 plus 2i over 3. So just separate the fraction and then we're good. So this is a third plus 2i over 3 when you separate this into two separate fractions. All right. Any questions about the simplification with the negative square root or the factorization of fractions here or separating a fraction?
It seems like you simplified by taking out the highest factor from 2 and 4i, and then you canceled it out, and then that's how you got it, and you just separated it. How come it's 1 over 3 and plus 2i over 3?
Yeah,
Or
so
is that like separate ways you can answer it?
this is the form that they want. Remember they said put it in this form. So what they want is the I. Actually, they want the I on the side, not the top. They want it like this when you type it in. Even though this is right, they want this. So when you add fractions, right, you keep the bottom the same and then you add the top part, correct?
Oh, all right. I see.
So you can just separate them if they're already being added.
Yeah.
And then over here, I noticed that there was a factor of 2 in common, and there was a factor of 2 down here, so I knew I could cancel this. Then here we just separate. These are our rules of fractions right here. Any questions on number 10? That's pretty much all of this assignment 11.
Yeah.
All right, we'll move on to 12. So on 12, they're going to assume that you're really good at factoring because you're going to need factoring in order to solve these problems. Okay.
Yeah.
Let's look at the questions. What do y'all think? Is this a quadratic? Is it linear?
Mm. It looks quadratic.
Yeah. So if you see a square on a variable, has to be on a variable, then you say quadratic, right? But since that's the highest power, this is a quadratic equation. Since it has an equals to something, this is an equation. It's not linear because you have a 2. So nothing crazy, right?
Mm-hmm.
So that's the first question. I just want to know, do you understand what a quadratic is?
Yes.
The next, then question number 2 is basically trying to test. Do you remember why we even care about factoring? Why we practiced that last week?
Because it will help with this assignment.
Yeah, it'll help you solve. It helps you solve quadratic equations. That's the whole purpose.
Oh, this one's easy.
So this one's already factored for us, right?
Yeah.
So if it's factored for us, what does the rule say? So if you watch the videos and took some notes, solve the equation. In order to solve a quadratic, it must be factored. If it's already factored, you set each factor equal to 0 and then solve. I'm sure you have all done this many times. And you don't have to keep the parentheses. Doesn't matter. All right, so since it's factored, you set each factor equal to 0. If I had 3 factors, I would do the same. And then solve. Subtract
You do
9 on both
the
sides.
9, and then you take away the 6.
Yeah. So any questions on this property that we used? It's called the zero factor property from here to
No,
here.
no question, sir.
And then the bottom part just we're just solving for x, right? That's all we did. If you need any more details, just let me know as we go along. Okay. So number 3, we're gonna have to factor ourselves. So I'm hoping that you practice that factoring section because this whole section expects you to be good at that. If not, you're gonna learn it as you go, I guess, right? Okay, I'm gonna use X for all of them just because it's prettier. Yep. So what factoring technique would you recommend that we talked about?
The AC method?
Yeah, we said we should use AC whenever this number is not 1, right? So A is 4, C is negative 27. A times C is, what's 4 times 27? That 108? Let's see. Negative 108. This one's a little big, but it's okay. So what factors of 108 will add up to negative 3? Since it's negative, one of them has to be plus, one has to be negative.
12 and 9.
Yeah. So 12, positive 12, and negative 9. sum them up over here. That would give me 3. So we need -12, 9, -3. So we're going to break up the middle term into -12 plus 9 minus 27. So broke those two apart, right? Remember we talked about that last time. Group 2 at a time. What do these two have in common? What kind of factor from the first two terms?
4.
Yeah, 4 and x, right? So factor 4x, you will get x minus 3. These two.
Nine.
Yeah, looks like a 9. So positive 9. We get x minus 3. Factor the x minus 3. We're left with this leftovers right here. Now we're back to the zero factor property. When you have two factors equal to 0, you can set them equal to 0. Add 3 on both sides. We got that. We got one of them. Subtract 9, right? Divide by 4. Okay, any questions on what we just did? Are you cool with the AC method? Are you cool with the factorization? And then solving for x here. Any questions on any of those steps? Any weirdness?
It seems familiar to me. It reminds me of where you used ABC, doing the factoring, and then you usually break it down to get the answer.
Yeah, I'm pretty sure you've done this before at some point, a long time ago.
It took a lot of practice to do because it was a long method. But I got it.
Yeah, guys, don't be scared to ask me or tell me if something doesn't make sense, guys. That's why you're here. And if it, because I'm just gonna assume I can't tell if it's super easy or super hard. Doesn't matter what I'm doing. So you got to tell me. All right. So this entire section is going to be the same thing over and over again. It's just the difficulty and the changes on the problems will be based on what factoring technique you have to use. So that last one was AC. The other ones could be something easy, like GCF, or it could be a simple trial and error or a difference of squares. It could be anything, right? So all the techniques from, I think it was section 10, right? All those have to be understood. Sorry, I had a message read to check. Alrighty. All right, so solve. It's basically what the answer was, but the work is what matters, right? That was number, I already forgot. 2930, number 4. Okay. All right. So this is a different technique. The last one was AC method. 10. It's number 5, right? Yeah. So the question is not going to tell you what technique to use. But what would you think? What would you suggest?
Um,
Actually, they did tell us, my bad. It said solve by using the square root property. The square root both sides. Whenever you square both sides, you got to tack on the plus or minus. So this is the square root property right here. So these cancel, leaving me with m equal to plus or minus root 17. So every time I square root both sides, I got to put the plus or minus on the right side. Okay. So I have two answers. So the answer you would type in is positive root 17 and negative root 17. Unless they have a plus or minus button, which I think they might. But technically, these are both the same. And this
this is
property.
on,
Oh, go ahead.
this is on 10, right?
Yeah, that was number 5.
Or on the sign 10. Like this is an example on the sign 10.
This is assignment number 12,
Oh, 12.
problem 5.
All right.
There is a plus or minus on the, because I'm doing it at the same time as you.
Cool.
There is a plus or minus sign, but I'm putting it in like plus or minus and then the square root and then my answer. But it's not going for me.
What was the question that you had?
Oh, I know what I did. I know what I did. I'm putting in yours and I'm not thinking about mine.
That's okay. That happens. No worries. 16, 17. So here, whenever you see a square somewhere in an equation, you should attempt to square root both sides. But here, notice how the square is on a binomial term. So a little different. So don't forget your plus or minus. So this cancels, leaving me with x plus 4. Square root of 4 is a 2. So now I have two things on the right. So to keep your head straight, so you don't mess it up, create two separate equations. That way you don't make a mistake. Because it's plus or minus 2, so this is equal to both. So this is technically what we're talking about. We have two different solutions. So subtract the 4. And get -2. Yeah, that looks weird. Subtract the 4. X is -6. You end up with two answers.
It's like the other one.
Yeah. Not too bad, right?
A little bit, yeah. It's not too bad. You're just kind of square rooting it. The fact that you have the parentheses inside the square root and then it turns to an x plus 4, it's kind of funny.
Yeah. So just remember the rule, right? Cancel squares. So
Yeah.
so far we had different types of factoring techniques. Okay. On this next one, they want us to use quadratic formula. So all these questions are basically solve whatever method you want, right? Just show your steps. So on this next one, I'm going to do it 2 ways. Well, I don't think we can. Let me see. Maybe actually. Oh, it's not great. So 2 ways. So here trial and error would be best, but they want us to do quadratic formula. So what are factors of -72 that add up to 6? What times what is 72? If you don't know it, write it down.
9 times 8.
9 times 8. But neither one adds up, right? What else could we use? So these add up to 1 and -1.
12 and 6.
Yeah, I think this is the better one. So this will be 12, -6, -12, and 6. So that'll be 6, -6.
Because that one is a greater number. Is that usually why?
Because it needs to add up to the middle one, the 6.
Oh,
So these first two don't add up to 6. So we gotta find another set. If a set doesn't exist, then it cannot be done this way.
Yeah.
That's when you have to do quadratic formula, you have no choice. But right now, we do have a choice. So it'll be minus 12, oops, actually plus 12 minus 6. And then solve for x. So that's one of the easier factoring techniques, but that's not what they want. But now we know the answer. So let's solve it the way they want. And find out.
It's easier to do the other method though,
Yeah, it is.
and it still gives you the same answer.
Correct. But the point is we need to practice quadratic formula, so let's start off with an easy one. Because the next couple, you only have one choice. So let's start off with the simple one to review the quadratic formula. So we know that x is equal to negative b plus or minus square root b squared minus 4ac over 2a. So, and that's coming from this general form here, right? So this formula came from solving this guy in general. So if I solve it for in general, that means I can use any ABC. But our question is giving us this here. So my A is 1, B is 6, C is negative 72. So plug it all in and we're good. So the solution will be negative 6 plus or minus 6 squared minus the 4 times the A, which is 1, times the C, which is negative 72, all over 2 times A, which is a 1. So just be careful with your signs. In here, we'll have 6 times 6, so that's 36, minus 4 times, negative 4 times 1 is negative 4, and negative 4 times negative 72, I don't know what that is, let's find out.
Be
There.
248.
Yeah. Oops. So it'll be negative 4 times 1 is negative 4, negative 4 times negative would be positive, so it'd be a positive 288 here. 36 plus 288. Be 24, right? Oops. 324. Does 324 have a square root? I think it's a pretty one, right?
18.
Yeah. So x is equal to negative 6 plus 18 divided by 2. And x is equal to, or negative 6 minus 18. -6 plus 18 would be 12. Divided by 2 is 6. So that's the answers we already knew, right? But we need to practice the quadratic formula. Are there any questions on number 8 here?
No, I do like the other method better because it's more simple and it helps me kind of figure it out easier and it's faster.
Yeah. But the other method only works sometimes. If the instructions tell you you have to do it this way, then you have to do it this way. But if it says solve and it doesn't say what to use, you can do whatever you want. Just make sure you get the answer and show your work. It all depends.
Yeah.
But I prefer using the best tool for each question. So in that last example, the first method was the best method. But the point is to practice all these.
Yeah.
So again, solve with the quadratic formula. Here's our formula. Use x instead. So -7x plus 3 minus 5y squared. So before you do the quadratic formula, remember it needs to be in this form, right? Equal to 0. And a must be greater than 0. So right now this a is negative. Put the y again. Oh, damn it. So I'm going to move this one over here by adding plus 5. So now I have 5x squared minus 7x plus 3 equal to 0. So my a is 5, my b is -7, my c is 3. So now once it's in this form, you begin using the formula. Okay. So your answer will be -7 plus or minus -7 squared minus 4 times a, which is 5, times c. 5 by 2. 2 times 5. All right, so negative, that's positive. Square that, that's 49. -4 times 5 times 3, that'd be 2060, right? All righty. 49 minus 60 is -11. So we have to deal with that negative. So remember, an I is going to come out, right? So our answer will be this. There's no real answer, it's just complex. Okay. Yeah, have any questions on that last one?
So what you did with I haven't been able to write the last the could you move the camera to the upper area? I haven't wrote that yet. Thank you.
No, of course.
It's not a question, but it was just more like I need to write the steps down.
No worries.
Thanks.
At the end of this equation, we don't move the I over because we haven't solved the square root in the +7 because we can't, right?
You mean put it in the back, or what do you mean?
Yeah, we put the I at the back, but we can't because we can't like finish the equation like completely.
I mean, you could put the I in the back, but it doesn't matter. This one, for some reason, they put it in front when it's a radical, but I prefer it back here. But it should accept either one. But there's nothing else we can do to simplify this further, though.
If
Okay.
we if this is how it's if this is how our answer ends, do they have like a symbol that says plus or minus for
Yes,
us?
they do.
All right, and if that's all we're able to do, then we type it in there. And
Yeah, you're gonna type this exact thing there. All right, let's take a short break and see if y'all have questions about either last time or today. I'll be right back.